So here we have Professor Kannan Modgalya with us. He's a senior faculty in the Chemical Engineering Department of IIT Bombay. He's an Iraj and Mehru Mehta Education Technology Chair Professor. He's a visionary and the driving force behind the FOSSEE project and the spoken tutorial projects that are going on in IIT Bombay. Sir, over to you.
Thank you, Payal. In order to save time, I already shared my screen. You can see the homepage of FOSSEE. As Payal mentioned, I've been promoting FOSSEE. FOSSEE stands for Free and Open Source Software for Education. Initially, we were called engineering education because the ministry said to have a focus. We did that very well. Then the ministry said, what about science? So we used to call ourselves Science and Engineering, although the logo was already created, so we didn't change the logo. Now the ministry said, what about all education? So we just call ourselves Free and Open Source Software for Education. The objective of FOSSEE is it is to promote open source software. Through that, using open source software, train a lot of people, especially our students and faculty members, and join hands with them and create even more. Work together, right? This is something that would have been clear to you already. Let me just give a brief overview of some of the things that we are doing, and then I will spend a little more time on OpenFOAM. So we promote Scilab in a big way, as you can see here. Python, eSIM. eSIM is electronic circuit design and simulation. Scilab is an alternative to MATLAB. Then we have OSDAG for civil engineers, DWSIM for chemical process simulation, OpenFOAM, you all know about. OpenModelica is an amazing simulation environment, modeling environment. PLC, programmable logical controller. So it's a hardware that we designed and built and tested, used, and so on. Then Arduino is another thing. We work with Arduino. Arduino is well known, but then we created a shield, and then we created a lot of experiments around it. In fact, we are in the process of releasing 5 books that we wrote using, we wrote on Arduino. Then R is an alternative to SPSS, for example. QGIS is a GIS tool. Focal is free and open source creative art library. There we promote Synfig Studio, which is a 2D animation. In fact, we are in the process of conducting a animation hackathon. 3-minute animations have to be created. It could be on a Panchatantra tale, or a Jataka tale, or unsung heroes. Maybe Payal can show the link for that during her talk. And then we have chemistry and science experiments here in Seoul. So that gives a brief overview of some of the things that we are doing. To give an idea of what is it people can contribute, let me open Scilab. Let me go to Scilab. And we have something called Scilab Textbook Companion Project. This is the flagship project of Scilab. In this, what we are doing is we take standard textbooks and provide Scilab code for solved examples of standard textbooks. For example, let me shrink a little bit so that you can see this here. Okay. So just to give an idea of this, so let me say, take mechanical engineering. In mechanical engineering, let me take fluid mechanics. So for 38 books, we have actually students across the country, for example. Here, this is VIT Chennai, Sastra University, IIT Guwahati. This is, they haven't put what college they are from. This is QSAT, Cochin, then Maharaja Agrasin Institute of Technology, and so on. So you can see that these are the students from these colleges that have contributed. Okay. For example, if you say this is the fluid mechanics and thermodynamics or thermomachinery, if I click that, so it recognizes that student. For example, this was contributed by Varun SS. BTech, of course, he's from IIT Bombay, and it was reviewed by a person by name Spandana, right? So I can actually download the Scilab code for all the solved examples. So we download it. Okay. Okay, actually, this is the code. What I will do is, let me download the PDF file. Okay. Here it is. So all the solved examples from this book are coded using Scilab. Okay. So for example, if you want to say 3-dimensional flows in axial turbo machine, okay, here is the code. Now, how do I understand the code? Just open the book, and example 6.1 explains the problem statement, and it has the solution, but we have the Scilab code here. Now, if you solve it, you'll get the answer, right? So this book is, let me just see, Dixon and Hall, right? So you have to open that book. Okay. Now let me tell you how you can use this also on the cloud. So let me go to the next page. So we have this website called cloud.scilab.in. So let me show a different example. It's electrical engineering. We choose control systems. We say, I will choose automatic control systems by core, and then select chapter, frequency domain analysis, select example, I'll choose body part. So this is example 9.15, chapter 9 in automatic control systems by core, and subdivision, category control systems, and in electrical engineering. So here it is. Now, if I execute, I get the answer, right? And it says, what are the margins, for example, gain margin, phase margin, and so on. Now, what will happen is, supposing I increase the gain to 5,000. So this part is editable. So I can ask the question to those of you who know controls, what will happen to the margins for this kind of system? It turns out the margin will come down here, as you can see here. From 14, it has come to 8. From 30, it came to 17. Margins have come down. And of course, that means anybody can say that what will happen, I can modify it, use it, and so on. Now, going back to, let's go back here. Remember the 634 books I had? We chose, for example, completed books are 634. So there are 1 lakh problems, solved problems, for which Scilab code has been given. It's all given by students across the country. Now let me take one more example. Let me go back to FOSSEE. Many more things are happening. For example, we are in the process of creating a cloud version of XCOS. XCOS is equivalent to Simulink, for example, right? Now let me take this example from DWSim. This is a chemical process simulator. And so we have something called flow sheeting project. So once again, what happens is students across the country have given solution to various flow sheets. You can see there are 253 flow sheets. Okay, what does the flow sheet look like? So let's look at this. Well, actually, let me show you another way to do that. DWSIM, I can open on the, here is the software I'm opening. DWSIM is a chemical process simulation, right? Okay, so while we are waiting for it, let's see the books where these students are from. This person is from Francis, from Ecuador, and then Gilda is from Ecuador, Chandini is from Warangal, Venganathan is from Tanjavur, and so on. So this is Vallabh Vidyanagar, Meet Dave, Mehul Kumar Sutaria from Surat. In fact, Mehul Kumar Sutaria did extremely well. He worked with us, and now he landed a very good job in a multinational, and he's doing extremely well, right? This person is from Rio de Janeiro, and so on, right? In Brazil, right? So, not sure why DWSIM hasn't opened. I just wanted to show you what a flow sheet would look like. Yeah, there it is. Okay. So it turns out that you can open a flow sheet and so on, but what I will do is, let me open it, because this DWSIM creator is a good friend of ours. So he has created all the flow sheets, for example. So the one I was trying to do was Kalina cycle. Open flow sheet, yes. Okay, here is the brief summary of it. But here is the, okay. So which means that this is the flow sheet. So you have a column, you have a heater, you have a compressor, you have you take it to a drum, right? And so on. So it what it does is explained in this abstract. What's there? Here it is. Okay. Background, flow sheet description. This flow sheet is given, results, and here is the reference. So it came in energy analysis of a Kalina cycle with double turbine and reheating. Came in materials today and 2021. So, so it is possible to do all of these. We welcome people to join hands to do that. There is only one thing that I want to do briefly. Let's go back to FOSSEE. We open OpenFOAM, and you have lots of things. In fact, we have a nice thing called case study project. You can see here, completed case studies. So 133 case studies have been given by people like you, by participants like you. And, you can download, you can solve it, you can modify it, and so on and so forth. Let me open testimonials here. I clicked here. So there are some interesting testimonials of people who had, worked with us, who were student contributors, who were full-time employees. For example, Divyesh, you were listening to, his testimonial is here. We have another person who is also doing extremely well. Ashley is his name. His testimonial is here, and so on. So I would encourage you to go and see how people are doing. We are constantly on the lookout for good people who will join hands with us to create spoken tutorials, to work with colleges and work for some time and then move on, either to do higher studies. For example, Ashley is doing a PhD here, whereas Divyesh has gone to industry. So either one is okay, because you go to industry now, instead you might say that I want to come after BTech. By the way, there are some benefits in joining for MTech or PhD as a staff member. You need slightly, you can get in with a slightly less mark, for example. I mean, you still have to do well. It'll still be 90s, your gate score, but then it can be less than the regular students. And the project will sponsor. And these students, in fact, end up doing better than students who join through a regular, 2-year MTech students. Compared to 2-year MTech students, those who are sponsored by FOSSEE, get their MTech degree, seem to do better. They spend 1 more year, but then their experience is counted almost as 3 years. So they, because all 3 years they continue to work, and even before getting sponsored, they work for some time. So all this is counted. So, which is extremely good, because you push your horizons, you learn a lot more by doing hands-on and being a good Samaritan, good citizen, helping the colleges, helping your alma mater, and helping students like you to do better. And then with the option of going to industry, but you can also go for higher studies here. And, because in these days, in an area like, OpenFOAM, computational fluid dynamics, I assume you know that the story of Dr. Abdul Kalam, who was denied, his Agni missile being, tested in Berlin. His team had gone because they said, come over, we will test it and give it to you. They refused in the last minute. But Dr. Kalam didn't give up. He found out that CFD could work. And he also found that Dr. Deshpande at IISc could make the code run 10 times faster, so that supercomputers were not required. Which is important, because at that time, even supercomputers were denied to us. And Dr. Kalam could have his missile tested, launched it. He became known as the missile man. Later on, he became the president of India. So CFD is extremely important. It's a high tech. It's a cutting edge of cutting edge work, research work can be done in CFD. And if you want to do CFD, OpenFOAM is a great tool. So you come to IIT, you come to FOSSEE, work with us. You work with us as an intern. In fact, if you see here, I was showing you one of the testimonials, the very first testimonial that I think is there, Manu Prithviraj. He actually joined us. He says that he joined a workshop first, a workshop like this. Then he joined as a semester-long intern. Then he joined as a full-time employee, and so on and so forth. So it's a great opportunity for all of you. I welcome all of you to make use of whatever you have learned, and the spoken tutorials are extremely useful. You can learn by yourself. Once you learn the basics, then internet has everything. You can do it yourself, right? You will have the confidence. You will get the confidence if you do spoken tutorials. If you do side-by-side learning and you practice, you do them all well, then you will have confidence that you are capable of solving such problems. Then sky is the limit, because internet has everything, right? So that's what I want to say. Our project is funded by the Ministry of Education, Government of India, FOSSEE. And as I mentioned already, the main emphasis is to promote IT training, promote the skill levels of students and faculty members in colleges across the country, and in fact, train them to the level they can contribute, give a platform for their capability through FOSSEE, because you saw all the links, right? Many students who contributed to us use this information for higher studies. People have got, scholarships, People have got internship opportunities in good companies. There was a student from NIT Trichy. He got an internship in Japan, for example. There was a student of another student who got admission to I think University of Pennsylvania. There was another student who got admission to Rutgers in New Jersey, and so on and so forth. So, make use of it, enhance your knowledge, and then contribute, give it back to the society, and so on. So it's an exciting area. And if you use open source software, there is no piracy. You're using legally. It's a licensed software, and you're using it legally and free of cost. And tomorrow, if you become an entrepreneur, once again, you can use it. If you are a faculty member and you are going to do a consultancy project, you may not be able to do it with the academic license of Fluent, for example, but you can use OpenFOAM. And not only that, supposing you help a small company, and that small company, if it wants to run that simulation, and if you had used Fluent, now they may not be able to afford it. Whereas if you use OpenFOAM, they can use it. So we have so many companies in, mechanical engineering companies in, for example, in Coimbatore, in Ludhiana, and places like that. And you can imagine how beneficial it will be that they can also learn, they can also simulate, and and so on. So with that, I'm going to conclude my brief presentation. If there are any quick questions, I'll be happy to answer. Thank you.